Hello everyone. In this video, we will discuss about the projection of lines parallel to one plane and perpendicular to the second plane. We will also see how to draw the traces of these lines. There are several possible orientations and locations for such a line. They can be of two types. They can be parallel to the horizontal plane and perpendicular to vertical plane, or be parallel to vertical plane and perpendicular to horizontal plane. And these lines can be in first, second, third, or fourth quadrant, or they can lie in more than one quadrant. Let's see these scenarios one by one. Line parallel to VP and perpendicular to HP. Consider a line AB parallel to VP and perpendicular to HP. The entire line is in first quadrant. Since the line is parallel to VP, the projection of the line on VP front view will have the same length as that of the line itself. If the line has a length of 50 mm, the front view will also measure 50 mm. Also, since the line is perpendicular to HP, the front view will be perpendicular to the XY line. The distance from A dash to XY line is same as that of the endpoint A from the HP. Since the line is perpendicular to HP, the projection on HP, the top view, is a point. The top view is obtained by looking from top. When we look from this direction, we will first see the endpoint B. The other endpoint A is not visible because it is right behind the endpoint B. So while marking the top view, we will put the invisible endpoint, small letter a, in symbol bracket. Also, the distance from the top view to XY line is same as that between the line AB to the vertical plane. While drawing the projection, the front view will be above the XY line and top view will be below the XY line. If the line is in second quadrant, both front view and top view will be above the XY line. The top view is DC with a C in symbol bracket to show endpoint C is not visible in the top view. If the line is in third quadrant, front view will be below the XY line and top view will be above the XY line. Top view is denoted by FE with a E in symbol bracket indicating endpoint E is not visible in the top view. If the line is in fourth quadrant, front view and top view, both will be below the XY line. Top view is denoted by HG with a G in symbol bracket to show endpoint G is not visible in the top view. Note that in all these projections, the dimensions are not shown. We will see how to draw the final projection of a line by solving a sample problem at the end of this video. Line parallel to HP and perpendicular to VP. Consider a line AB parallel to HP and perpendicular to VP. The entire line is in first quadrant. Since the line is parallel to HP, the projection of the line on HP, that is the top view, will have the same length as that of the line itself. If the line has a length of 50 mm, the top view will also measure 50 mm. Also, since the line is perpendicular to VP, the top view will also be perpendicular to the XY line. The distance from top view A to XY line is same as that of the endpoint A from VP. Since the line is perpendicular to VP, the projection on VP, the front view, is a point. The front view is obtained by looking from front direction. When we look from this direction, we will first see the endpoint B. The other endpoint A is not visible. It is right behind the endpoint B. So while marking the front view, we will put the invisible endpoint A in symbol brackets. Also, the distance from front view to XY line is same as that between the line AB to the horizontal plane. While drawing the projection, the front view will be above the XY line and top view will be below the XY line. If the line is in second quadrant, front view and top view, Both will be above the XY line. Note that the front view is D dash C dash with a C dash in symbol bracket because endpoint C is not visible in the front view. If the line is in third quadrant, front view will be below the XY line and top view will be above the XY line. Front view is F dash E dash with the E dash in bracket, which means end E is not visible in front view. If the line is in fourth quadrant, front view and top view both will be below the XY line. Front view is denoted by H dash G dash with G dash in brackets indicating endpoint G is not visible in the front view. Trace of the lines. Now let's understand what is meant by trace of a line. Trace of a line means the imaginary point obtained by extending the given line to the reference planes. When the line is extended, the point at which it touches the HP is known as the horizontal trace, denoted by HT. When the line is extended, the point at which it touches the VP is known as the vertical trace, denoted by VT. For a line parallel to VP and perpendicular to HP, even if we extend the line, it will not touch the vertical plane. Hence, such lines have no vertical trace. But when the line is extended, it touches the HP and that point is the horizontal trace HT. For a line perpendicular to HP, its HT coincides with the top view. For a line parallel to HP and perpendicular to VP, even if we extend the line, it will not touch the horizontal plane. Hence, such lines have no horizontal trace. But when the line is extended, it touches the VP and that point is the vertical trace VT. For a line perpendicular to VP, its VT coincides with the front view. Sample problem. A 60 mm long line AB has its end A at a distance of 20 mm above the HP. The line is perpendicular to HP and 40 mm in front of VP. Draw the projections of the line. In this question, end A is 20 mm above HP. The position of end B is not given. So there are two possible solutions for this problem. We can assume endpoint B is either above HP or it can be below the HP. Let's first assume the endpoint B is above HP. Since the line is perpendicular to HP, it will be parallel to the VP. We know that the projection of a line on a plane to which the line is parallel will give the true length. Since the line is parallel to VP, its projection on VP, the front view will have the true length 60 mm. The front view is perpendicular to the XY line. Since the endpoint A is 20 mm above HP, its front view A dash will be 20 mm above the XY line. The top view is a point and is obtained on HP. It is denoted by BA. Since the line is 40 mm in front of VP, top view will be 40 mm away from XY line. Since the line is parallel to VP, there is no vertical trace. If we extend the line to HP, it will touch HP on the top view itself. That point is the horizontal trace HT. After rotating the HP, the top view and HT will go below the XY line. To draw the projection, first draw a thin horizontal line, mark XY. From the XY line, draw a thin projectile line 20 mm above the XY line, mark A dash. From A dash, draw a thick line perpendicular to XY line with a 60 mm length, mark B dash. From XY line, draw a thin projectile line below the XY line at a distance of 40 mm. Mark the top view BA. Mark the horizontal trace HT. Mark the dimensions. This is the completed projection. Now let's assume the endpoint B is below the HP. That means the line is in both first and fourth quadrant. Since the line is parallel to VP, the front view will have true length, that is 60 mm. A dash will be 20 mm above XY line and B dash will be 40 mm below the XY line. Total length of the front view is 60 mm. The top view is obtained on HP, denoted by AB. When viewed from the top, endpoint A is visible and B is not. So we will put a B in symbol brackets. This top view is 40 mm away from XY line. Here we don't need to extend the line to find the trace. The line is already touching the HP on top view. That point is the HT. After rotating the HP, top view and HT go below the XY line. To draw the projection, first draw a thin horizontal line, mark XY. From XY line, mark A dash 20 mm above the XY line. Draw a thick line from A dash towards the bottom, perpendicular to the XY line at a length of 60 mm. Mark B dash. In the same line from XY, mark the top view 40 mm below the XY line. Mark HT on the same point. Mark the dimension. This is the completed projection. As a summary, if a line is parallel to one plane and perpendicular to the other, the projection on the plane parallel to the line will give the true length, and this projection will be perpendicular to the XY line. The projection on the plane perpendicular to the line is a point. The trace of the line coincides with the point. If the line is parallel to HP and perpendicular to VP, top view will have true length and is perpendicular to XY line. Front view is a point. VT coincides with the front view. There is no HT. If the line is parallel to VP and perpendicular to HP, front view will have true length and is perpendicular to XY line. Top view is a point. HT coincides with the top view. There is no VT. Hope you understood the concept and thank you for watching.